In this lesson, we'll discuss big idea number 1. What are redox reactions and how do you describe them? And we'll focus on learning target number 2. By the end of this lesson, you should be able to write a balanced chemical equation for a redox reaction under different conditions. Not all redox reactions occur at pH 7. Writing complete balanced equations for these reactions may be too difficult to do by inspection. We'll start by learning how to balance half reactions. Depending on if the reaction is done at neutral, acidic, or basic conditions, the strategy used to balance is different. Neutral conditions is what we've been doing so far. Write the correct formulas for the reactants and the products. Then balance the atoms using coefficients like normal. Add electrons to balance the total charge, left side versus right side. Here are two examples. In A, zinc is being oxidized into zinc plus ions. So I write the reactants and the proper products. Because I have one zinc on each side, I don't need to add any coefficients. In order for zinc to go from a neutral charge to a 2 plus charge, it would have to lost 2 electrons. Another way to figure out that 2 electrons are needed is by looking at the charge differences. The charges on the left side and the right side need to be the same. Here I have a net charge of 0, and on the right side I have a 2 plus and 2 1 minuses. That also equals 0. Pause the video here and write the reduction reaction with sulfur changing into sulfide ions. Here's the answer for example B. In order for sulfur to change into an S2-, it needs to gain electrons. I have one sulfur on each side, so I don't need any coefficients in front of my formulas. Because I have a 0 charge on the left side and a 2- charge on the right side, I need to add 2 electrons as reactants in order to make the charges balance. If a reaction is done under acidic conditions, follow these steps. Write the correct formulas for the reactants and products. Balance any atoms other than oxygen and hydrogen first. Then, balance any oxygen atoms by adding water molecules to the side where you need more. Balance any hydrogen atoms by adding hydrogen ions. And finally, balance the charges by adding electrons. Let's have a look at example 2. I start by writing down the reactants and the products, and it's always a good idea to leave some space. Since I have one nitrogen on both sides, I don't need any coefficients in front of my chemicals. Now I balance my oxygens by adding waters. I have 3 O's on the reactant side and only 2 O's on the product side. Therefore, I'll add 1 water molecule to give me 3 O's as products. That unbalances my H's. I now need to add 2 H pluses to the left side in order to balance the hydrogens I included in the water. Because H pluses are present, that proves that this reaction happens under acidic conditions. Now to add electrons. The net charges on both sides have to be equal. I have a 1- and 2 1+. That gives me a 1+ charge on the left-hand side. On the right-hand side, I have a 1-. That means I need to add 2 electrons to the left-hand side in order to knock it down to a 1- charge. Pause the video here and try out example B and C. Here's the answers for example B and C. Start by writing the reactants in the products. I have 1 chromium on each side, so no coefficients are necessary. In order to balance the oxygens, I add 4 waters onto the left side. That means I need to add 8 H pluses on the right side to balance my hydrogens. Let's check out the net charge on each side. I have a 3 plus on the left. On the right hand side I have an 8 plus and a 2 minus. That gives me a 6 plus. In order to knock that down to a 3 plus, I need 3 electrons on the right hand side. For C, my sulfurs are already balanced. In order to balance the O's, I need to add 2 waters onto the left side. To balance the H's, I need 4 H's on the right side. To balance the charges, I will also need 2 electrons on the right side. That gives me a net charge of 0 on each side. If your reaction happens under basic conditions, balance it like the reaction was acidic. That takes you to step number 3. Then add enough OH1 minuses to both sides of the equation to react with any H pluses present to make water. This will change your reaction from an acidic one to a basic one. Simplify the reaction by removing any water present on both sides. You will usually see some spectators. And then balance the charges by adding electrons. Here's an example. First, start by writing the reactants and the products, and make sure to leave room on both sides of the equation to add things. Now, because I have 1 nitrogen on the left and 2 on the right, I need to double the amount of ammonia used. To balance the oxygens, I need to place 1 water on the left-hand side. To balance the H's, I need to add 8 H pluses to the right side of the equation. I have 2 times 3 gives me 6, plus the 2 H's I added in the water. Now to change this into a basic reaction, I will add 8 OH1 minuses to both sides of the equation. That keeps all of the atoms balanced because I added it to both sides, and it will neutralize the 8 H pluses and make 8 waters. Because there are OH1 minuses on the left side of the equation, this reaction occurs under basic conditions. Notice that I have 1 water on the left and 8 on the right. That means I have 1 water spectating. It's always a good idea at this point to rewrite your equation so that it's a little neater for me when I mark it. Now I have to balance with electrons. I have a neutral charge here and 8 1 minuses there. On the right side of the equation, I have a neutral charge. That means in order to balance this, I'll need 8 electrons on the right-hand side. It's always a good idea to double-check your equation. I have 2 n's on each side. This gives me 6 H's plus 8 more, 14 on the left, 7 times 2, 14 on the right. 8 O's on the left, 1 plus 7 more gives me 8 O's on the right. Pause the video here and try out example B. Here's the answer to example B. I'm going to need a coefficient of here to balance my bromines. That means to balance my oxygens, I'll need to add 6 waters onto the left-hand side. And 12 H pluses in order to balance my hydrogens. Now that all the atoms are balanced, let's change it into a basic reaction by adding 12 hydroxides to both sides. My hydrogens and hydroxides will react with each other and make 12 waters. I have 6 waters on the left. That means 6 of my waters will be spectating. Now to balance with electrons. I have a 12 minus on the left-hand side, and I only have a 2 minus on the right-hand side. That means I need to balance with 10 electrons on the right-hand side as products. Let's make sure everything's balanced. I got 2 Brs and 2 Brs. I have 12 Os. This gives me 6 plus 6 more in my water, so 12 Os. And 24 H's. 6 times 2 gives me 24.